Alright guys, so we're going to do some studying. We're going to work on some things you should know for your test tomorrow on November 11th. Parallel segments. First of all, parallel segments are segments that do not intersect but are on the same plane. Not intersecting on same plane. Skew segments are not intersecting but they're on different planes. Okay, so that's the key difference. Different planes. Perpendicular segments, as you know, they intersect and they make 90 degrees. Parallel planes are whole surfaces that won't intersect. That's a terrible drawing, but so let's look at this picture down here. If I label these like A, B, C, D, E, F, G, and H, example of parallel planes are plane A, D, C, B, this plane right here. Remember, to name a plane you only need 3 letters, so I could say plane A, B, C, and it is parallel to the plane down here. These are whole surfaces that won't intersect, so it's parallel to plane EHG, for example. Okay, you can name that many different ways. Parallel segments, for example, will be, perpendicular segments. AB is perpendicular, make sure you put the segment symbol. AB is perpendicular to BG, for example. There's lots of examples on there. Skew segments, these are on different planes. So AB would be on this top plane or in that back plane. So for example, AB is a skew segment with maybe CH up here in front face or on the right face, but it's not touching. It will never touch that back face or segment AB. So AB could be a skew segment with CH. Hope this drawing isn't completely messed up. But hopefully that makes some sense to you. Parallel segments on the same plane but will never intersect. So AB and DC is an example. Parallel segments. Alright, that's that. Watch it a few times if you need to. Alternate interior angles theorem. So we're talking about angles, not angels. I misspelled that. Angles formed by transversals. So alternate interior angles theorem, example of alternate interior would be alternates across the transversal, this being the transversal. This is that line right here. It's the one that crosses 2 lines. It alternates across the transversal and is on the interior. That would be, example would be angle 2 and angle 8. Okay, that example of 3 and 5. Okay, so, and alternate interior angles you should know are congruent, as long as this line is parallel to this line. If it's not parallel, then that can't be true. Okay, but examples are 2 and 8. This is all the interior. Let me highlight. This yellow part is the interior. This light blue part is exterior. And all that's exterior, all that's interior, all that's exterior. So when we're talking about alternate interior, 2 and 8, they're congruent, or 3 and 5. Alternate exterior, 1 and 7, they are also congruent. You could also have 4 and 6. Corresponding angles postures, they're in the same position, so like examples 1 and 5, they're both on the top of the transversal and on the left side of the parallel lines. There's a parallel line, here's a parallel line, both on the left side. So example would be 1 and 5. There's 4 other sets. Those are also congruent. Let's get a little messy here. Congruent, congruent, congruent. Same side interior means it's on the same side of the transversal. So example would be this one and this one, same side interior. And on interior, so it's in that yellow section. Examples would be 2 and angle 5. These you know are supplementary, so they'll equal 180 degrees. Same side exterior is the same idea. Same side exterior is green one. For example, 4 and 7. Angle 4 and angle 7. These will equal 180 degrees. Alright, so make sure you know all of those. You guys are doing pretty well with that stuff. When do you use the converse of the theorems in the previous page? So all of these theorems, these are all theorems or postulates. When you use the converse is if you're trying to prove that two lines are parallel. And they tell you some angles are congruent or supplementary. So if I told you this one and these two angles right here are going to add up to 180 degrees, then you could say they're same side interior. But if I was trying to prove that this line is parallel to this line, I'm going to use the converse of the same side. So once again, if you are proving lines are parallel, that's simple for parallel. Maybe I should write out the word so this is clear. If you're trying to prove lines are parallel in capital letters, then use converse of theorem. If you are proving the lines are parallel, so they told you this information is true, but you are proving the lines are parallel. This one's parallel to this one. Then use the converse of the theorem. Please don't forget that. Writing equations in point-slope form. This is your point-slope form. You might want to use this on your note card you get to use. A note card front and back. If anything you would like to write down, 3 by 5. Don't go for a bigger size. 3 by 5. So this is point-slope form. You're going to replace the slope and you replace the point. So replace with this information that will be given to you, or you have to figure it out. So in this example, you have a slope of 2. You got a point right here, point -3, 4. So y minus 4, because that's the y value, equals the slope of 2 times x minus, and replace the x value. Minus is part of the formula, so replace the x1, -3. Do a little bit of simplifying. Don't distribute, just simplify a bit. That's it. Okay. There's an example. There's plenty more in your book if you need it. Find a slope between 2 points. So you guys know this formula, y2 minus y1, x2 minus x1. If you don't, make sure you know that. x1, y1, x2, y2. So you got a -4, y2, minus the 3, which is the y1. Start with the x2, x2 minus the x1, so it's a -2. Do some simplifying. This is a -7. Make sure you do your math correctly there. This is the same as adding, so that's 3. Slope is -7/3. Parallel slopes, as you should be aware by now, are the same. So if I was starting off with this one, my parallel slope would also be -7/3. Opposite reciprocal slopes are perpendicular. So perpendiculars are opposite. Some people will say negative reciprocals, but opposite reciprocals. Okay, this is perpendicular. This is when they cross and make 90 degrees. So this one is -7/3. The perpendicular would be a positive 3/7 in this example. And something I didn't mention much in class, but you should be aware that the slopes are perpendicular also if their product is -1. So what that means is product is the answer to a multiplication problem. So if you times the normal slope, the original slope, which is -7/3, you times it by its opposite reciprocal, you'll get -1. This is always going to happen. Anytime you take the original times its perpendicular, you get -1. There's a couple questions related to that. You don't necessarily need to know it. You could figure that out on those questions. But that's about all the information you need for that. Are the lines parallel, perpendicular, intersecting, or coinciding? So first you need to make sure that the equation of the line is in slope-intercept form. So if I give you one that's like 2x plus 3, and another one that is, I don't know, say, how about something like 4x plus 2y equals 6. You got to make sure this is in slope-intercept form, which means get the y by itself first. So minus 4x minus 4x is 2y equals a negative 4x and plus 6. You cannot combine these two. They are not like terms. Then you'll divide by 2. Y will equal a negative 2x because you divide this and you also divide that plus 3. So these two are not parallel. They have to have the same slope, as I said on the last page. They're not perpendicular because they have to be opposite and reciprocals. Right now they're just opposites. They're just going to be intersecting anytime slopes are different, but not opposite reciprocals. So anytime slopes are different, they're going to be intersecting. Which means it just has a different steepness. So one has something like this, the other one has something like this. They're not parallel or perpendicular, but they just intersect. Coinciding means that the slopes are, everything is the same. You get one equation, and then you get another equation when you convert into slope-intercept form, and it ends up being the exact same thing. That means they're coinciding, which just means everything is the same. Slopes are the same, y-intercepts are the same. Okay, so here, maybe you don't write this on your little note card. Parallel slopes means same slope, different y-intercepts. Here is perpendicular, means they're opposite reciprocals. Y-intercepts don't matter. Here, intersecting means that they're different slopes. Y-intercepts, once again, don't matter. And then coinciding means that the slopes are the same and the y-intercepts are the same. Yeah. Let's move on. I think that's it. That's pretty much all the information you need to know. Let's go through it all one more time. Identify these vocabulary words. You can identify those segments. Know angles that are formed by transversals and how to solve equations using them. Use a converse when you're proving lines are parallel. Write equations in point slope form. Here's point slope. Just plug in the slope and plug in the point. That's it. Find the slope between 2 points. So here you go. And then are lines parallel, perpendicular, intersecting, and coinciding? Okay, there's one more thing I forgot to mention. How do you write an equation in slope-intercept form? In slope-intercept form. I think there might be one question on your test about this. When given a point. Or 2 points. So if you need this information, you can keep listening. Otherwise, you're pretty much done. So for example, 1, 2, and 3, 4. First, you got to figure out slope. 4 minus 2, 3 minus 1. This is 2 over 2, which means slope is 1. Then you got to figure out the y-intercept, which is called the b. The b is called the y-intercept. So pick one of the points. Say the first one. This would be x and y. Substitute what you know. 2 equals 1, which is slope, times the x value, which is also 1. Okay, hopefully it's not confusing. This one comes from this number right here. X comes from that number right there, plus b. So in this case, oops, that's not 2, that's 1. In this case, I do some math, and subtract 1, you'll get 2 equals, I'm sorry, that's not true, 1 equals b. Sorry about the sloppiness there. So you know that the y-intercept is b. Write your equation in slope-intercept form. Here's your slope, 1x, plus the y-intercept is b. These probably weren't the greatest numbers because there are a lot of duplicates, but hopefully you get the idea. There you go. Fill in the information that you have figured out. Okay. If you got any questions, send me a message to Edmodo. That's pretty much it, guys. Good luck. Do some studying.